absolutely desperate now to test my new Sharp 8-track player, and it's quite funny. They're obviously very proud of the fact that it's a solid state stereo 8-track player, so that's wonderful. And the main reason I bought this is because it's got the record function on it, which I really wanted to be able to record some modern music. But one thing is standing in my way, is that there's no plug on it. Well, that's not quite true. I did a quick PAT test on this earlier, and it failed miserably on the earth continuity test, and I think it failed for a couple of reasons. The plug that was on it was the dirtiest, blackest, horrible, most manky plug I've ever seen, and also the wire in here is pretty thin, and it's quite a long cable, so I suspect that the fact that the plug was very manky and it's quite a long thin wire, I think that's why it might have had problems passing the more modern PAT test. So what I'm going to do is I'm going to go cut a bit off the cable, and we're going to have another go. And you never know, with a bit of luck and the tongue at the right angle, it might just pass. So and that'll be good enough for me. Well, to be honest, if it doesn't pass, it'll still be good enough for me because I'm not bothered. And I've also just spent about half an hour trying to find a plug. It's funny, at one time everything came with plugs on it, so you always had a supply of plugs to rob. But the plugs on pretty much everything I own these days, everything's got IEC connectors on it, and the plugs are all moulded on. So these are becoming a bit like rocking horse teeth. Don't worry, I won't subject to you watching me wire up this plug. One, it'll be very, very boring, and two, there'll be a lot of plug people, won't they, telling me that I haven't left the earth cable, a little bit longer than all the others, or I didn't double it over before I put it inside the screw, or I don't know, all these plug aficionados that are out there. So yeah, let's just get it on. That was interesting. I just noticed that I took a 13 amp fuse out of this, and yeah, this cable came off a logic analyzer, so yeah, probably shouldn't have had a 13 amp fuse in it. I've never really understood this kind of fascination that manufacturers have of plugs, of providing them with a 13 amp fuse in them, because I can't think how much equipment actually wants a 13 amp fuse in it. It's actually, there's not that much equipment that needs a 13 amp fuse, really, is there? I know everybody knows this, but it's amazing how many people don't do it. Maybe it's not that important anymore, but when you wire a plug, it's always a good idea, if you can, to leave the earth wire longer than all the others. That way, if the cord does get pulled out, it will disconnect the live wire before it rips out the earth. I suspect the fine art of plug wiring isn't going to last very much longer, is it? Because as I said earlier, everything comes with moulded plugs on it these days. So yeah, it's going to be a dying art, this. I also wonder how long things like 13 amp plug sockets will actually last, and what will replace them. I don't think we'll be using U-beam. If any of you are familiar with that, I'll come across these U-beam chargers. Yeah, I don't think we're quite there, and I don't think Mr. Tesla will get his way, so I don't think we'll be sucking electricity out of the air. But yeah, who can tell? What's the other piece of plug wiring advice? Probably not to tighten the terminals up ridiculously, because if you actually do tighten them up ridiculously tight, what you'll actually do is you'll actually just crush the copper and distort it, which will actually kind of really just push the wires out of the way rather than making a good connection. So you only need to nip them up. You don't need to tighten them so hard that you're going to cut the wiring. I guess the other thing about wiring plugs is the little cord grip as well. That again, there's no point in actually tightening these up so far that you start to damage the cabling. For a terrible minute then I thought I might have got one of them plugs that has the what do you call it? It has kind of like the cable strain relief built into the back of it, so you've got to thread the plug casing onto the lead first. You won't believe how many times I've done that. It must be well, probably pretty much every time I put one of them types of pluggers on, I always forget to thread the plug body through first, and that's bloody annoying, isn't it? At one time you could buy 2 amp fuses, couldn't you? Did I imagine that you could buy 2 amp fuses? I'm sure you could. And I seem to think you could also buy 1 amp fuses from RS. I think you can still buy maybe 1 amp fuses. I need to buy some 1 amp fuses because they're good to put in valve radios and stuff like that. Anyway, we're going to put a 3 amp in, it'll have to do, it's all I've got. Shall I demonstrate my plug wiring skills? I'm just going to adjust that earth wire before I do that, because somebody will complain about it, won't they? They'll say, oh, I can see a little bit of copper showing through, I don't want to see that. So we'll just make a very fine adjustment on that earth cable. Okay, does it pass? Have I passed the plug wiring skill test? I seem to remember when I was a scout leader many years ago, there used to be a badge for the kids teaching them to wire plugs. I bet you can't do a plug wiring badge now. Probably not even allowed to switch on a plug socket, I suspect. Okay, one grubby but perfectly wired plug. Actually, I always think plugs are really strange. I mean, I don't claim to be any kind of electrical genius by any stretch of the imagination, but it's amazing, isn't it, how when you buy old equipment and you know, you take it home and you buy it off the market or car boot sales, and you know, you always have a look inside the plug, and it's amazing how many examples I've found over the years of plugs that just like fall apart in your hand, or they've got tin foil in them, or half a nail, or they're, you know, they just wired up completely wrongly. You know, you'd think that wiring a plug would be the simplest thing on earth, and it is the simplest thing on earth, but so many people get it wrong, don't they? No doubt I've committed some plug wiring sin there, and everybody's going to leave it in the comments. Okay, this is my PAT tester, and it's an Megger PAT32, and I bought this again second hand off eBay, and I think I paid about £25 for it, but it's been a pretty useful piece of equipment. And I think I said in another video, you can pick up these type of manual PAT testers on eBay for pretty much going for nothing, because the modern PAT testers log all the appliances that they test. I think it might even be a requirement of the PAT testing regulation now that the equipment has logging built into it, but certainly the people who do PAT testing, they find it's much easier if they have a system that logs all the equipment and prints out a test label and stuff like that. So that's what they tend to use. So the market, you know, the second-hand market for these is just flooded with old equipment. Now, this is not going to be a video on how to PAT test things. I'm not a qualified electrician. I've not been trained to PAT test equipment. I haven't read the manual to how you even use this PAT tester for probably a couple of years. So please don't use this as a video to go PAT testing equipment, because don't come crying to me if you manage to electrocute yourself, or even worse, if you manage to electrocute somebody else. So it's not a tutorial video. I don't normally give safety notes. I kind of think that most people who get electrocuted probably deserve it, but yeah, I suppose in this litigious world in which we live, we should give it a go. Right, at the moment this PAT tester's not doing very much at the moment. It's what you do is the piece of equipment that you want to test, you actually plug it into the plug socket here, and the first test that we're actually going to do is we're going to make sure that the piece of equipment is actually connected, and by that is the piece of equipment that has to be turned on. So if you actually press the circuit test button on here, what it actually does, it measures the continuity between live and neutral, and it's actually measuring infinity at the moment. So that would lead me to believe that this 8-track player is switched off. But we've immediately got a bit of a problem, because you probably can't see, believe me, there's no on switch. So how do you switch one of these 8-track players on? Well, I'm going to take a guess that you switch it on in the same way as the 12 volt 8-track players you find in a car. What actually switches it on is putting the tape in closes a micro switch. So what I'm going to do is I'll bring you in so you can actually have a look at the display on the PAT tester. I'm going to put the tape in, and hopefully if I've got enough hands and fingers and I can press enough buttons at once, you'll be able to see something happening when I put the tape in. And this is showing an infinity reading at the moment. There's like a little 8 symbol on its side, that means infinity. So it's measuring a very, very high resistance between the live and the neutral conductor. Now you probably wouldn't expect a very high resistance for this type of equipment. You know, it's got motors in and probably a transformer. You'd actually be expecting a pretty low resistance. So this is telling me that it isn't switched on. So let's switch the 8-track player on by pushing the tape into it. So hopefully you'll hear the tape going in. We should get a different reading here. So we'll push it in now. Okay. So we put the tape in, the reading has immediately changed to 0.19 ohm, 0.19 ohm, and that's probably about what I'd expect without actually knowing what's under the cover of this. It's difficult to know. That does to me sound like, you know, less than ohm, probably a little bit low for a transformer, but yeah, could be. Don't know what's in there, so we'll take that as being okay. So the next test that I'm going to do is something called earth continuity. Now, what an earth continuity test checks is that the earth wire in your plug there, which is this pin, as you all know, the earth continuity check makes sure that this pin, this earth pin, is actually connected to any metalwork on your equipment. So what we can do is we can connect an ohm meter and to the earth pin of your plug like this, and what it's going to do, it's going to test the continuity of your earth circuit. So that's going to be from this earth pin right to the metal body of this equipment. So we need to find a bit of metal. This looks like a good piece of metal, so we'll try that. And you hear the beep there. So we can tell that this earth pin is connected to the metal part. Now, why is an earth important? Well, if for some reason the live conductor gets in contact with the body of your equipment, if you didn't have an earth connection here, the body of the equipment will become live. So the purpose of earthing the chassis, if you like, is to actually create a short circuit. So if a live conductor touches the metalwork, it creates a short circuit to ground, and if everything's arranged correctly, that short circuit will draw so much current that it will instantly blow the fuse in the plug and prevent you getting an electric shock. So I can see that we've actually got an earth continuity through the pin down the flex into the body of the equipment. So all's well and good. And to be honest, before I had a PAT tester, I used to just do that because it was about the best thing I could do. You can put your meter on ohms. Let's just null out the meter reading. So basically, okay, so these test leads have got about 0.6 of an ohm, 0.5 of an ohm just in the test leads themselves. So if we go to the body, it's actually reading about the same. So it must be a very low resistance, this, which is what we want. That's good. So to me, everything looks good at the moment. So why would you bother using a PAT tester to test the earth bond? Well, there is a good reason, and it's because the current that I'm doing this test at when I use my ohm meter like this, there's pretty much no current there. These type of meters are designed to work with semiconductors and transistors and things that would be damaged by current, so they pass pretty much no current. Well, again, so why is that important? Well, just because this meter is saying we've got a good continuity, which we have got good continuity, but what we don't know is how much current we could pass down this earth wire before the earth wire would fail. So what the PAT tester actually does is it forces a lot of current down the earth wire to try and make the earth wire fail. So we've just done this measurement now using our ohm meter. Let's try doing it using the PAT tester. Now on this particular PAT tester, others may be different. You've got to use a connector on the side of here, which is it says 10 amps on it, and you need to connect that to a piece of metalwork. And what it's going to do is, much like we just did with the fluke ohm meter, it's going to take an ohm reading, but it isn't going to take it at microamps like the meter is. It's going to actually put 10 amps through it. And what you do is you press this button down and it will automatically do the test, and it'll tell us if it passes or fails. Now you don't want to do this test for too long, because 10 amps is quite a lot of current, and it's quite a lot of current probably for this thin wire that's in here, so everything is going to be heating up. So you want to do the test quite quickly, and you don't want to keep just repeating the test, because you could damage the equipment. Okay, so I'm going to do the test now. I'm going to press the button down, and it passes, so that's good. So what we can do, just to verify the test as well, is we can make it fail. So I'll just disconnect the test lead off the body of the equipment. So we've lost our earth continuity, we haven't got a circuit anymore. So, and if I press the button now, we just come up with a fail. Now, just to finish off with, I just wanted to just give a demonstration of why perhaps a digital voltmeter isn't the best thing to measure the resistance of your earth cable to your piece of equipment and try to do your earth bond test just using one of these. Now at the moment I've got my piece of cable. I've got it connected between the common and the input lead on the fluke meter, and it's varying a bit, but we're getting a measurement there of about 0.7 ohms. So if I took that reading, I might think, oh, 0.7 ohms, that's quite a good connection. But I've actually got a bit of a con going on here. I've actually cut away the wire, and I don't know if you'll be able to see it. Let's see if we can get it to focus. So I've cut away the insulation on the wire, and the camera probably won't show it up there, but there's only one strand of earth wire now. Now that one strand, it only has a very low resistance. It actually just shows, it's showing 0.5 of an ohm at the moment. So that would make you think it's really good. But the problem with this one strand of wire is if you get a fault, this one strand of wire will burn out. And it will burn out before your fuse burns out. And what that will do is that will leave the metal body of your equipment live. So I think we should be able to demonstrate that. So what we've done is, we've actually connected this piece of earth wire. This is just a mock-up. This earth wire here would be running inside your cabling, but it could have damage inside, and this damage can occur if the cable, for example, keeps getting twisted backwards and forwards, or maybe it's under the carpet and it's being walked on. So you can get this type of damage occurring, and it wouldn't be apparent. So what we've actually done is I've actually connected one side of the cable to the chassis of the equipment and the other side of the cable to our PAT test lead. And what I'm going to do is I'm just going to turn the PAT tester on now, and we'll do the test again. So what I'm hoping will happen is when we press the test button, so much current will pass through here that it's going to burn out the cable, which could actually lead to a very unsafe situation if this cable was actually inside your main flex. So let's press the button and we'll see if we can see anything. 1, 2, 3. Hopefully you saw that. I saw that glow and then burn out. So if that earth cable was actually inside your mains flex, it's quite likely the body of this piece of equipment is now live, because your protective earth has burnt out and you're none the wiser. So that's why using a traditional ohm meter to measure the earth continuity, it's not a good test to do. However, it's a better test to do than not doing any test at all. So the final test I'm going to do is what they call an insulation resistance test. And what that test is to do is it checks the resistance between the live and neutral conductors and the earth system, because in an undamaged working piece of equipment you should have no current flowing into your earth. Now, as before, when we were doing the earth bond test, we actually used quite a high test current, higher than what our digital fluke meter was able to produce. An insulation resistance test meter does something a little bit similar in that it doesn't use a high current. What it actually does is use a high voltage. Now, I don't know what this one uses. I think it'll probably be about 500 volts, because you tend to do an insulation test at twice the operating voltage. So all I have to do is I just have to press the button, wait a few moments, and it comes up with a pass. So that's okay. So I was doing quite a bit of filming and talking there. The reality is to actually pass test a piece of equipment takes probably only 30 seconds. And this type of PAT tester meter, this Megger meter, makes it very, very easy to PAT test equipment. So I would say that if you are serious about doing repairs on TVs and radios and especially older equipment, that a PAT tester like this is, I wouldn't say it's essential, because you can do all the tests without it, but it makes it so quick and convenient, and it's all in one nice box and it's easy to use. I could PAT test a piece of equipment in probably 20 or 30 seconds. That's all it takes using one of these testers. But there is a lot more to PAT testing than just plugging the equipment in, and the most important part is the visual inspection, which is a large part of the actual test procedure. So any piece of equipment that you buy, you should really carefully check the mains flex, check that the covers on the equipment aren't broken, check that there's no exposed mains wiring, check that the plug's got a fuse in it, and check that the plug's wired correctly. All of these things you can do without any fancy test equipment, and most equipment faults that I've seen when I've had bad equipment, I wouldn't have needed the PAT tester to show them up. It was simply that just a visual inspection showed something wrong. It showed the mains flex was cut, the earth wire had pulled out, all things like that. All you need to do is just use your eyes. So yeah, so just spend a bit of time doing a safety check. Now there's lots and lots of videos on YouTube by people who actually know what they're doing, as opposed to me. You got to remember that this channel is called AlltheGearNoIdea, and as you can probably tell, I have pretty much no idea what I'm doing from one moment to the next. So what I would say is don't take my word for it. Go and seek some proper training or some better information. There's lots of videos on YouTube with professional people who know how to do these types of tests and demonstrate how to do them correctly. Go and watch some of their videos, or better still, go on a training course. There is a chap called John Ward who I'm a big fan of, and I think he must be an electrical engineer by trade, and he gives lots of information about checking equipment and various types of tests, and actually how electrical equipment functions. I would highly recommend watching some of his videos. He's really good and really entertaining. Right, that's all the safety bollocks over. And another really useful piece of advice is don't work on live equipment. Yeah, and another piece. Oh bugger! And oh, that's all tangled up there now. And the other advice I'd probably give is don't work on equipment when you're pissed out your head, because I've been in the garden. It's a beautiful day here today, and I've been in the garden all afternoon getting drunk. Yeah, it was obviously a splendid idea to come in and make a video on safety testing.